And welcome back, everybody. This is Chapter 3, Part 3. This is the last part and the longest video in the Chapter 3 series. We're going to start out by talking about something called a Z-score. A Z-score is the number of standard deviations that a given value x is above or below the mean. The Z-score is calculated by, and there are two formulas depending on what you have. If you have a sample, and if you have the whole population, we're here. Same formula, it's just this is population. So this is the population mean, population standard deviation. This is the sample. Sample mean, sample standard deviation. And I'd like to break this up into here. And when we're talking about z-scores, we are so many standard deviations away. So out here, we're 2 standard deviations away. Remember, if you remember from the empirical, that means that 95% of the information is between -2 and 2. And we have some properties to look at. And again, I want to make it clear. Let's put a little color here. So between -2 and 2, so this is considered your usual. And out here is not usual or unusual. When we're talking about normally distributed data. All right, next up we have, let's do some properties here. The z-scores are expressed as numbers with no units of measurement, meaning they're not in inches or feet or anything like gallons or anything like that. There's no unit at all. They actually cancel each other out. If an individual data value is less than the mean, then the z-score is negative. So if a data is less than the mean, then we're going to have a negative z-score. If it's more than the mean, then it's going to have a positive z-score. So here's our practice for this. When Steve Jobs was CEO of Apple, he earned an annual salary of $1. The CEOs of 50 largest U.S. companies have a mean salary of $1,449,779 and a standard deviation of $527,651. Convert Steve Jobs' salary to a z-score and then decide if it's usual or unusual. Well, z is going to be his $1 minus the mean divided by the standard deviation. We'll put that into a calculator. 1 minus 1,449,779. Make sure you hit equals first. Divided by 527,651. And I got negative, it's about -2.7476. Again, you should be doing this calculation as well with me, verifying my numbers and so on. And this is definitely outside of the usual range, right? -2.7 is going to be back here in the not usual range. So this is unusual. To answer the second part of the question, is it unusual? Yes, it's unusual. And I think we can all agree that $1 compared to almost $1.5 million is definitely unusual. You don't need to worry about Steve Jobs. He had lots of money. All right, next up. And we're going to come back to that z-score is going to pop up here and there. Next up, we have the definition of something called a percentile. This is a, you might have heard this word before, and it's denoted as piece of 1, piece of 2, up to a piece of 99, which set the data into 100 groups with about 1% of the values in each group. Now, this is important. The subscript here, meaning the little number that you see here, 25 here, 99 here, that means that that's the percent of data that is below that location. We're going to talk a lot about that. That's going to be a little much. You may need to watch the video a couple of times maybe to kind of catch that. So for example, the 25th percentile is here. Means that at least 25% of the data values are below it, which means about 75% is above it. But this is the main thing, is that we want at least 25% of the data below it. And here's a little table here. Let's talk about some notation here, and then we will find percentiles. So n is going to be the total number of values in the data set. In this case, I believe that's 40. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 4 is 40. K is the percentile being used, meaning 25th percentile, 25% of the data is below it. L is the location, and this is the actual percentile, piece of K. So we're going to start here. Now we're back to the chocolate chips. As we're looking at this count here of what's we're going to start here, and we want to find the percentile for the cookie with 23 chocolate chips. So we're going to go to the lowest place where there's 23 chips, and we want to know how much. Notice we're in the 11th location, so how many values are below it? That's 10. So our K that we're going to be doing here, there are 10 values out of 40 times 100. Meaning 25% of all of the data is below this location here. And that's true, right? This is 1/4 of everything. So we would answer piece of 25 is 23. Meaning, what's the percentile of the cookie with 23 chips? Well, 25% of them have less chips in them, meaning the cookies have less chips in them than this location here. We're now going to go in the other direction, using the same data. We want to find the value of the 18th percentile, meaning I want to know which of these has below it 18% of the data. Well, this one we're going to use this formula. So the location is going to be K. In this case, that's the 18 out of 100 times the 40. These two formulas are actually the same formula. They're just flipped around a little. And we can go 18 divided by 100 times 40. And we get 7.2. But we want to guarantee, so if I go to the 7th location, 1, 2, 3, 4, 5, 6, 7, 7th location, below it is not a guaranteed 18% of the data. So I always round up on this. This is the 8th location. So 1, 2, 3, 4, 5, 6, 7, 8. So this means piece of 18 is 22. Let's do it again. So I'm missing out on the data just a little bit here. So now I want the 25th percentile. So that means I'm going to go 25 over 100 times 40. And that's going to give me exactly 10. Now, this is going to, when we get a decimal like this, excuse me, when we get a decimal like this, we always round up. When we get an exact number like this, like we have here, that's going to cause a problem. Because if I go to the 10th spot, 1 through 10, so here's the 10th spot, below that is not 25%. So I actually have to go halfway between the next two. So I'm going to go the 22 plus the 23, and I'm going to find its mean. So halfway between 22 and 23. So we would say p sub 25 is 22.5. And we actually can compare that answer. Oh, I had it all below. Sorry about that. So 25 over 100 times 40 equals 10. Again, the 10th location is here. Below it is not 25% of the information. So I took the 10th and 11th position and found the mean. You only do this mean thing when you do this calculation and you get an exact number, which we did in this case. That's going to take some practice with those percentiles. It's easy to mix up which direction you're going. All right. Now we are to quartiles. So you can see that the number 4 is in there, quart, right? Quattro, it's all the same. Quarter. All right, so basically quartiles, the first quartile means that 25% of the information is below it. The second quartile, which is the median, means that 50% of the information is below it. The third quartile means that 75% of the data is below it. And this is going to generate what's called a 5-number summary. Minimum value, Q1, the median, Q3, and the maximum value. We'll talk more about that in just a moment. Q2 is the median, and Q sub 3 and Q sub 1 are the median of these bottom two chunks here. And we need to find the interquartile range, which is going to be Q sub 3 minus Q sub 1, meaning the middle data there. And the lower fence, so the range, this is the range of the middle 50% is the IQR. IQR stands for interquartile range. Lower fence is going to be Q sub 1 minus 1.5 times the IQR. The upper is Q sub 3 plus 1.5 times the IQR, the interquartile range. Now, if a data is below whatever this calculates out to be, then it's what we call an outlier. If any of the data are above whatever this upper fence is, then that's considered an outlier as well. And we'll talk about what to do with those here in just a moment. For this first example, this is commute times for 30 employees. You're going to need to put this into list 1 or list 2, wherever you want to put it. I've already preloaded mine in there, so I'm not going to pause, but if you're taking notes like you should be, pause the video right now and actually start putting the data in so that you can participate in this here. So here I have, in list 1, my list 1, I have all 30 pieces of data. I'm going to run the one var stats again. That is located stat, calculate, one var stats. Again, you may have a different interface. You may be like stacked up there. Either way, it needs to be list 1 for me. Whatever list you put yours in, that's what you should put in. And I'm going to hit go. And although it doesn't look like we have the information that we want here, if I scroll down, we end up with our 5-number summary. The minimum value they give us, there we go, 30. Q sub 1 is 56. Q sub 2, or the median, 72. Q sub 3, 83. And the max is 99, meaning the largest number, the smallest number. Nope. Minimum is 31. I wrote that wrong. Minimum is 31. All right. We are going to find the IQR. And if you recall, that's Q3 minus Q1. So our IQR is 27. And we will need the lower fence, which is Q1 minus 1.5. It's always 1.5 times 27. I'm getting 15.5. The upper fence is Q3, 83, plus 1.5 times the IQR, which is 27. Okay, so do we have any data values that are less than 15.5? No, we don't. The smallest one we have is 31. Do we have any data values that are larger than 123.5? No, we don't. The largest we have is 99. So in this case, there are no outliers. All right. We have another example. Please take a moment and pause the video and put this into, I put mine into list 2. You can clear your list 1 and put it into list 1 wherever you'd like. It's fine. I'm going to change the mode on this one in case other people have a different mode. Stat Wizard is turn it on. All right, part A. Compute the Z-score corresponding to the hemoglobin, that's this data here, of Blackie, that's the name of the cat one presumes. Those are cats. 7.8. So 7.8 is right where my finger is, right here. So, part A, let's scoot that up and over. Part A is to find the Z-score. So 7.8 minus, now I need the mean to do that. So what I'm going to do is I'm going to run one var stats again. My data I put for the cats I put here in list 2. And now the interface is different because I wanted other people to see, so I'm going to change that to L2. And very nicely I get the mean, 10.08. Just a quick recall, C equals x minus x bar over standard deviation. Standard deviation in this case is right here, 1.8858. 8, 8, 5, 8. And that's going to give me 7.8 minus 10.08. Make sure you hit equals first, don't just divide. Now divided by 1.8858. So our z-score is about negative 1.209. And again, you should be doing this with your calculator for the practice. Please don't just watch me do it. I already know I know how to do it. I want to make sure you can do it when the test comes. All right, that's part A. And let's interpret the result. Notice that we're within 2 standard deviations. So this is a usual. All right, part B. Determine the quartiles. Well, the data's already in there. I'm going to run one vars again against list 2. Maybe yours is list 1, wherever you put the data. So this gives a minimum of 5.7. Q1 is 9.15. The median is 9.95. Q3 is 11.1, and the max is 13.4. So here are our quartiles. This answers part B. Very easy with the calculator. I mean, it's almost no work on your part. And now, the biggest place that students make mistakes is they put the data in incorrectly. So make sure you count the data, make sure that you have the same amount, make sure that they all have one decimal point. You don't accidentally have 106 instead of 10.6 or something like that. Part C says compute and interpret the interquartile range, the IQR. Just a quick reminder is Q sub 3 minus Q sub 1. Which 11.1 minus 9.15, which gives me 1.95 is my IQR. Part D. Determine the lower and upper fences. Are there any outliers? So we'll do that. So the lower fence, once again, is here. That's going to be Q1, that's 9.15 minus 1.5 times the IQR, which is 1.95. I'm getting 6.225. And the upper fence is going to be 11.1 plus 1.5 times 1.95. So 11.1 plus 1.5 times 1.95. And again, make sure you're practicing this. So here's my lower and upper fence. All right. Are there any outliers? Well, let's see. Are there any numbers that are less than 6.225? Yes, we do. 5.7 is less than our lower fence. So 5.7 is an outlier. How about this? Do we have any values, data values that are bigger than 14.025? No, we don't. We're good. So there's only one outlier in this case. So I want to ask you the question, if we can't use 5.7 because it's an outlier, then the next minimum is now going to be 7.7. And that leads us into, we're going to graph this information on something called a box plot. So here's our 5-number summary, which again, you just run one var stat to get that. You'll have to scroll down. And I'm just going to make the box and whisker. We used to call it box and whisker. They call them box plots now. So I'm dating myself with that one. But what I want to do is I want to do a box plot based on the hemoglobin of the cats from before. So I'm going to toggle back and forth between this information and the actual graph. So I'm going to say this is 5. And what was the maximum again? Maximum was 99. No, I'm sorry. So I'll say 14 is the max. 5, 6, 7, 8. Okay, so here's how this works. First of all, I'm going to take 5.7. I'm going to put an asterisk there. That's our outlier. All right, our next lowest data point, once we get rid of 5.7, is 7.7. So that's our new min, 7.7. 7.7 is about here. Put a dot. Next up, we have 9.15 for our first quartile. 9.15. For our median, 72. Median is 9.95. That's way over here. Q3, I keep doing that. 11.1. And our max is 13.4. And you can see why we call it a box and whisker plot. You can see the box and the whiskers. And here's our outlier way over here. So if there's an outlier, we don't include it. We go to the next data point below 5.7. That's 7.7 in this case. And we can use the Boxplot and Quartile to describe the shape of the distribution. So it's symmetric when this is dead center, which it clearly is not here. When it's skewed like this, it's skewed right. Skewed right. So this one's definitely skewed right. If it was the other way, then it would be skewed left. And that's it for this.